Okay, so here's 7.3 logarithmic functions. We're going to write equivalent forms of exponential and logarithmic functions, and then we're going to evaluate logarithms. This really can be done, a lot of this mental math, and I will show you how to do this later with the Inspire. But for the most part, a lot of this is just trying to understand what is a logarithm. So a logarithm is basically the exponential, or is the exponent to which a specified base is raised to obtain a given value. We're used to seeing an exponential function say at b to the x power is equal to some number a. Well, a logarithm would rewrite that as log base b, notice how the base is down now, a little bitty number down below, of a is equal to x, where the answer on a logarithm is the exponent that would give you a certain thing. And you can see that the b is the base, a is the answer value, and x is the exponent. Okay, let's look at an example. Let's convert from exponential function to a logarithm. So if you see in this first example, I am going to say 2 to the 6th power is equal to 64. Okay, so I'm saying my base is 2, so I'm going to write that as log 2. And then I'm going to put the 64. And that's equal to 6. So notice here what I'm saying is log base 2 of 64 is equal to 6. Where I am saying that 64, the log of that 2 of 64 is that exponent of 6. 2 raised to the 6th power would have given me 64. So logarithms, this number here is what it's like my answer, and I'm trying to figure out what's the exponent that would give me that answer. Okay, so my next one, 6 to the 0 power is equal to 1, would be log base 6 of 1 is equal to 0. 5 to the negative 2 is equal to 0.04. That would be log base 5 of 0.04 would be equal to negative 2. And 3 to the x is equal to 81. So then I would say log base 3 of 81 is equal to x. Now, later on, we'll start figuring out this type of problem saying, well, what exponent would give me in base 3 would give me an 81. And you can go 3 times 1, or 3 times 3 is 9, that's squared, times 3 again is 27, that's cubed, times 3 again is 4. So I would say there that x would have been equal to 4. Okay, now let's convert the other way. Let's go from logarithms to exponents, back to exponential form. So in that one, we're going to say, let's see here, log base 10 of 100 is equal to 2. Well, then I'll say that's 10 squared is equal to 100. Log base 8 of 0.125 is equal to negative 1, then I would say 8 to the negative 1 power is equal to 0.125, 125 thousandths. Log base 12 of 1 is equal to 0, that's 12 to the 0 power is equal to 1. Okay, again, all these are fairly easy. Okay, some properties you should always keep in mind. If you're saying the log of a certain base is equal of that same number, that would be equal to 1. For example, log base 6 of 6 is equal to 1. Or the log of any base of 1, that would automatically be equal to 0. Log base 6 of 1 is equal to 0. Notice how again I'm saying these things. I'm saying log of the base, or log base of, and then I'm saying of, like say that number, and then what's it equal to. Also, keep in mind that a logarithm in base 10 is called a common logarithm. If there is no base shown, it is assumed to be in base 10. For example, if I were to say log 5, I am saying log base 10 of 5. In a lot of your older calculators, when you did logs, you can only work them in base 10. With our calculators, with the Inspires, you can actually type in the bases. So this actually, the Inspires make it a lot better to do logarithms than your 83s, and I think there's a way to do it with the 84s, but I am not sure. Okay, so let's evaluate some basic logarithms, some really easy logarithms. Log 100, or I'm sorry, 1000, what's that equal to? Now again, notice there's no base. So I'm going to say that's log base 10 of 1,000. And you're looking at, okay, well, what power of 10, what exponent of 10 would give me 1,000? Well, just count the zeros. So that would be 3, because 10 to the third power is 1,000. Log 1/4, or log base 4 of 1/4. Okay, what number or what exponent would give me 1/4 when I'm raising the 4 to a power? Well, think about it. First off, it's a fraction, so that's a negative. And then you're going, well, 4 raised to what gives me 4? Well, 4 to the first power, so then it would be -1. Log 0.001. Okay, I wanted to do this one. Notice this is in base 10. If you were doing it mentally, and it's very simple. And also notice I snuck in an extra little 0 in the front. That's where it makes it easy. If you count all the zeros, 1, 2, 3, 4, 5, including the one in front of the decimal, then you could say this is -5 because it's in base 10. 10 to the -5 power would give you 100,000ths. Okay, and then log 25 of 0.00 or 0.04, that's -1. That one you would probably have to type into the calculator and figure out. Actually, I think in this case, decimals are a little bit harder to work with than it is with fractions. I think fractions would have actually been easier, because that would have been, like this one right here, could it be rewritten as log 25 of 1/25, and that's a lot easier to see as -1 than the 0.04. So, that's about it. One last thing I want to make note of is if f of x is equal to, let's say, is an exponential function, b to the x power, then its inverse would be the logarithm function, log of b to the x, log of b of the x. For example, if I said f of x is equal to 3 to the x power, that's the exponential function, then its inverse would be log base 3 of x. And I'm going to show you the graph of those. There's your y equals x line. Remember, that's the line that they reflect over. There's f of x, and now f of x, or the inverse, the logarithmic function, is right there. And notice how they're just reflections of each other. That's pretty much it for 7.3. The main point on this is going to be evaluating logarithms and also working doing the conversions. 7.4, you're going to start doing a lot of the properties, so that one will probably be a little bit longer. But that's it for today.